Hi, I'm Miles Harrison, and this is a year of generative AI, looking back on 2023 as part of NLP from scratch. And today is December 28th of 2023. So it's been an incredibly transformative and disruptive year in AI. There's absolutely no denying that. And as the year draws to a close, let's take some time to look back on some of the key developments and milestones that we've seen, as well as look forward at what's to come in 2024 and beyond. So 2023 represented a pivoting from the AI that came before into the age of generative AI. In fact, I would argue that 2023 was the year of generative AI, and we may talk in the future of 2023 or perhaps 2022 as being a sort of year zero, the time prior to which we could actually trust that the content we see on the web was not generated by a model, but had to be written, drawn, or otherwise created by a human being. And lately, with how fast things are moving, it's becoming increasingly difficult to know sort of even what is real anymore. And I tend to think about this on almost a daily basis. So, in case you are not aware, this is the Gartner hype cycle. And for the past year, we have been precisely here. Gartner put us squarely in the peak of the hype cycle for generative AI earlier this year, and we've been there since. The rise of Gen AI and everything around it has been absolutely meteoric, and it shows absolutely no sign of abating. So many people are making comments saying things like it is becoming harder and harder to keep up, incredibly difficult to keep up with the pace of everything that is happening because the pace of advancement in the field has accelerated so much. We've heard about new breakthroughs and research and startups and models and funding rounds almost literally every day. So the question is, how did we get here? And I don't think anyone would argue that realistically, the thing that brought us here is this. ChatGPT was the innovation trigger, which made generative AI and large language models a household term. It was and continues to be an incredibly disruptive force, both in the data space, across basically all industries, as well as just the broader general world at large. And this is what made Mr. Altman and OpenAI household names, made him into a global celebrity of sorts outside of tech. And obviously there was a lot of controversy with his on social media with his firing and then almost nearly immediate rehiring by OpenAI in November. But if you look at the pace of ChatGPT's adoption, it truly was meteoric, unprecedented, if we could say that. It was the first service to reach 1 million users in 5 days, and it reached 100 million users in just over 2.5 months. And as far as I'm aware, this is the fastest any service or product has been adopted in the history of tech, if not in all of human history. So the question is why? Why was the adoption of ChatGPT so meteoric? And large language models are not actually that new, right? The attention is all you need paper, which introduced the transformer architecture on which the vast majority of LLMs are based, actually came out from Google Brain in 2017. And other organizations have been doing work with LLMs, integrating them into products and services, but in some cases, maybe the consumer is not directly seeing this. For instance, you can see here this blog post from Google in October of 2019, where they are announcing their integration of BERT, which is kind of the foundation model of foundation models, into search to improve results. And again, this is way back in the fall of 2019, which seems like ages ago. And GPT-3 itself was first introduced in 2020. So again, the question is why? Why was ChatGPT so disruptive? And I think the answer is twofold. On the one hand, we have the application of reinforcement learning from human feedback, or RLHF, using a separate reward model and keeping humans in the loop to steer and shape the behavior of models after pre-training. So OpenAI was not the inventor of RLHF, but to the best of my knowledge, they were the first to apply it to language models, and they were definitely the first to make the big bet of doing so massively at scale. And that bet ended up paying off quite well, and the rest is history. as we know. So this was really the key innovation that resulted in ChatGPT being so convincing and blowing so many people's minds, if you remember what that looked like on social media when it first came out in November of 2022. The second reason, which I think a lot of people overlook, actually has nothing to do with data at all, but instead with how AI is presented. It is really about user experience. LLMs had existed in research, were gaining steam in industry, but the importance of the way ChatGPT was presented from a user experience perspective absolutely cannot be underestimated. The way that you were able to interact with it in a very conversational, human manner in the browser was, I think, new for a lot of people and set it miles apart from the chatbots that we were used to in the past. So that's how we got here, and ChatGPT was clearly the innovation trigger, or at least the most publicly noticeable one, that catapulted us into this year of generative AI. And with this new paradigm comes some new language around it. So in this presentation, we're going to talk about large language models. We're going to talk about foundation models and multimodal models as part of that. So first, let's talk about large language models. As noted, the vast majority of the models we've seen released over the last year, with the exception of image and video generation models, are based on what is called the transformer architecture, first introduced at Google Brain in 2017, as I already mentioned. In fact, many people almost use the term large language model to be synonymous with the transformer architecture, although they are not. There are some other model architectures we are seeing coming out and being scaled up, but the vast majority of large language models we see are still based on the transformer architecture. From Google Brain, we had the original authors of the Attention is All You Need paper going to other companies like Cohere and Character AI, which was listed actually as the #2 consumer use of generative AI behind ChatGPT by Andreessen Horowitz. The original use for the transformer architecture was a fairly simple translation task, which now seems kind of trivial by today's standards in both what it was doing and the scale of that. But this model architecture and the innovation of self-attention turned out to be very powerful and generalizable. And now we see companies like OpenAI with ChatGPT and many of these other companies now applying these things to build product at scale. So looking back into the past a little at how we got here, you can see it's really amazing how the scale of these things has grown. In 2018, we had GPT-1 from OpenAI, which had 117 million parameters. And then about a year or so later, in February of 2019, we had GPT-2 with 1.5 billion parameters. So that's a power of 10 in less than 2 years. And we see other models from sort of the usual suspects in the space following what appears to be a kind of power law curve here. And then if we look ahead into 2020, whoa, it's off the charts with 175 billion parameters with GPT-3. So another power of 10. And not on this chart, because I couldn't show it, is GPT-4 in March of this year. And that no one really knows exactly how many parameters GPT-4 has, as OpenAI has declined to disclose this, but it's believed to be a mixture of experts model with about 1.76 trillion parameters. So we're seeing a 10,000-fold increase in the size of these models over a space of about 5 years. And the scale of these models, both in terms of their parameter size as well as the scale of the training data, they really appear to be following Moore's law. And it's interesting to see, to think about just whether the sky actually is the limit and just how far things will go in the future. Getting a bit dated now, but if you're interested, there's a good paper from earlier this year charting the growth of LLMs. And you can see in gray on the right there, that's the decoder branch of models, of which GPT is one. So a lot of the research in the past, like with BERT in pink there on the left, was done with encoder models. And then in the middle, we have full encoder-decoder models. But most of that has slowed now, and almost all the research has been focused on decoder-only models because of the success of ChatGPT and OpenAI. And really all these decoder models do is predict the next token based on previous tokens, but despite that being what they do, we've still seen amazing things that they're able to do and how they've been applied in industry. We've also seen some problems, one of which remains is what is called the problem of hallucinations. So here I fed Llama 2, which is a popular LLM from Meta, a completely made up URL of a Wired article that does not exist. This is not a real article. If you go to this URL on the wired.com website, it is a 404, but the model will happily generate a summary of this completely made up article. And so when people do this, we call it bullshit. But when models do this, we call it hallucination. And there's a lot of discussion around this, around how to sort of solve this problem, and whether or not this is an intrinsic property of the models, and it's just something we have to live with. And Andre Karpathy made his thoughts on this clear on Twitter. So there are approaches you can take to deal with this sort of thing, approaches like retrieval augmented generation, or RAG, where you're combining basically traditional information retrieval or search against a data store or knowledge base with an LLM. So you're giving the capability to work on top of some sort of knowledge base. However, this doesn't completely solve the hallucination problem, because now in many cases, your model will just happily hallucinate around the facts or data that you have provided. So in addition to hallucinations, model evaluation also remains an open problem, although many people try to pretend that it is not. This presentation from researchers at Princeton in October, called Evaluating LLMs is a Minefield, was quite popular. It talked about how many of the benchmarks people use to evaluate these things are in fact contaminated. That is to say that the models have actually been trained on the data that is used in the evaluation sets. So every benchmark you see coming out of companies or researchers around claiming that their model is the latest and greatest and outperforms other LLMs, take any of those things you see with a generous shaker of salt. And I would argue that evaluation is still very much broken. And this is another problem that remains very open in the space, and I'm interested to see how this will evolve in the future. So now we can talk about foundation models. This is a term that came out from researchers at Stanford in the Center for Research on Foundation Models, or CRFM. And this was introduced in a paper in 2021. And what they were trying to say here is the types of models we're now seeing, the size of these models, they're using the traditional term of just a machine learning model isn't sufficient, because the impact they are having, the way they're disrupting industry and research and even society is of a much greater scale. So they've come up with this new term of foundation models to talk about these kind of models. And we look a little bit back in the past at the original foundation models, that is to say in 2017 or 2018, we have the BERT model from Google, which I already mentioned, which is an encoder-only model. GPT, obviously from OpenAI, decoder only for text generation. And then the T5 model from Google, which was kind of a Swiss Army knife model. It could do many, many different things. They trained it on many, many different tasks. So these models remain openly available, and their weights, at least for up to GPT-2, remain open and to use. And so people are still using these and fine-tuning these models like these. We're now seeing foundation models being offered as product. Companies like OpenAI and with GPT, obviously, and others, Cohere with their command model, Anthropic has Claude. Stability AI is a notable outlier here, as they're doing text to image generation, and they don't use transformer architecture, but instead are using a different type of model, diffusion models. Inflection has their Pi chatbot, and they'll soon be offering the recent Inflection 2 model available by API. And then we see companies like AI 21 Labs with their Jurassic model, and other companies and models. So we're seeing a lot of these being offered as product, but we're also seeing these being offered as a service. And we're seeing this from the big companies that we know, companies like Microsoft offering this on Azure, AWS, and Google, and they're offering both proprietary and open foundation models as a service through the cloud services they provide. So we're seeing these now offered as a service and also integrated into services that these companies already have and the products that they make around. So the future of machine learning we find ourselves in is looking a lot different from the past of data science and AI. There's really just a lot of APIs, and it's starting to look a lot more like traditional software development as opposed to doing some kinds of data science work. And there's a bit of a problem with this. I call this the double black box problem, because in the past we had deep learning models and it wasn't exactly clear how they functioned or how they made their predictions. And we saw the rise of fields like explainable AI or XAI to deal with this. But now we have what I call the double black box problem, because now not only now do we have these deep learning models where it's not clear how to interpret how they make decisions, but they're now buried behind some API. They are a product that is owned by a company. And in many cases, the data that was used to train these models, the architecture of these models, how they function, things like that, these details are not being made known or being omitted from the research papers about the different models. So we're seeing this disturbing trend where it is becoming more and more opaque in industry. And it's very ironic that a company called OpenAI is becoming less and less open over time. And I have to sometimes remind myself that they were originally started as a nonprofit. And you can see this trend reflected in this Foundation Models Transparency Index, or FMTI, from the Center for Research on Foundation Models, which was released earlier this year. They had 100 different indicators of transparency. None of the foundation models scored very highly, and it's very worrying to me when a company like Meta is at the top of any sort of transparency score you have. On the other side, we see companies like Hugging Face championing open source and open models as part of their platform and promoting open alternatives. That being said, they are still a company that makes profit. They are also backed by a lot of the big companies I was just talking about. They have a lot of funding being sunk into them to raise their valuation, which is fine. And we also see from a lot of these companies an explosion of open models coming out. We have models like the Llama 2 model from Meta, which was incredibly popular, released in July of this year, and spawning a whole generation of offspring, basically. Obviously, the earlier GPTs from OpenAI now becoming proprietary with GPT-3 and above, but their Whisper model for transcription remains open and free to use. I already mentioned Stability AI with Stable Diffusion, which was released back in 2022, but now they built upon that this year with Stable Diffusion XL and Turbo. Eleuther AI building on the work they did with GPT-J and GPT-Neo-X by releasing the Pythia series of models this year. Mistral with their very, very popular Mistral 7B model, the French startup. And they've now released their Mixtral Mixture of Experts model very recently, earlier this month. Mosaic had their MPT model, and they've been acquired by Databricks. Salesforce had their XGen 7B model. The LM-Sys group released the Vicuna series of models, and this was built upon later with the Guanaco as part of the QLoRa research, both of these being fine-tunes of Llama from Meta. DESI had their DESI LM model and Coder, and they recently released a new version of this. Databricks had the Dolly model, which was a fine-tune of Pythia. Microsoft focusing on smaller models with their Phi series, and they just recently released Phi 2. Hugging Face recently released a distilled version of the Whisper model, which is smaller and faster to use than OpenAI's full Whisper. Earlier this year from the TII in Abu Dhabi, we had the very popular Falcon model. Replit made their coding model openly available. And then from Asia, we see models like Quen from Alibaba, Yi from O1.ai, and DeepSeek LLM, all of these models being highly bilingual in English and Chinese. So a real explosion of open models, and expect this space to continue expanding into the next year and beyond. Great. So finally, we can talk about multimodal models. As I already mentioned, Whisper, one of the models that remains open from OpenAI. It's a family of highly accurate multilingual speech-to-text transcription models, or what in the domain we would call models for automatic speech recognition, or ASR. And people are doing pretty amazing things with this building product because it's open. There are libraries like insanely fast Whisper that was released, where you can do things like transcribe hours of spoken audio locally on your machine in a matter of minutes. And as I mentioned, Hugging Face released Distilled Whisper, a smaller version that is also free and faster to use. From Meta in the translation space, we saw the seamless M4T model, which stands for Massively Multilingual and Multimodal Machine Translation Model. This model not only does machine translation, but it also does it in a multimodal way. So it can transcribe and translate speech to text, but it also does text to text, text to speech, and speech to speech. And it's highly multilingual. The number of input languages for each modality combination does vary, but it is around 100 languages for each. And this is a space that Meta is very interested in, doing a lot of active research here in the past, working with what are called low resource languages. And it's my belief that their ultimate goal is to have eventually a kind of universal translator through our smartphones like they would have in Star Trek. And we're already starting to see things move in this direction with some real-time translation apps, and it's a pretty exciting space. In the text-to-speech domain, going the other way, 11 Labs is a leader here doing a lot of great work. They now have a multilingual model to do this, released in August, and the voices that come out of it are very, very lifelike. It's very expressive, human-like voices coming out of this. It's not like the old text-to-speech you would hear on public transit or something like that. There are also other projects in this space. We see work being done by Microsoft, working with Project Gutenberg to do things like programmatically create audiobooks that sound very expressive and lifelike, even though they were generated by a model. So it's very amazing how far this technology has come in a short amount of time. In the audio modality as well, we now see music being generated from large language models. Stable Audio was released by Stability AI, and you can type different text prompts and then get short music clips generated. Google later this year released their Lyria model, which does the same sort of thing, and they're working to integrate that with YouTube creator tools in what they call Dream Track, and we can assume that they will continue to integrate it with other product that they offer. So the future of being a creative, doing creative production work is going to evolve and look a little bit different. I would not be worried if I was a musician yet, but perhaps I would be starting to get worried if I was in the business of making elevator music. Now, moving over to talk about images, I already mentioned Stability AI a number of times, who are the leader here with Stable Diffusion back in 2022, and now Stable Diffusion XL. That's actually a mixture of experts model with only 2 experts. You have a backbone image generation model and then a separate refiner model. They now also, as I said, have Stable Diffusion Turbo, which generates images almost as fast as you can type. OpenAI has DALL-E, and they released DALL-E 3 this year, which was a new version. This is also a diffusion model, being overshadowed somewhat. I don't know if people talk about it in isolation as much as it's now kind of part of GPT-4 with GPT-4's multimodal capabilities. Google had their Imagine model earlier this year, which did images as well as short videos. And they recently released a new version of this. But again, Gemini has multimodal capability. And so just like GPT and DALL-E, maybe as far as the public is concerned, there's like a fair bit of overlap there. Meta has their EMU series of models, and they just recently released this as a standalone product with what they call their Imagine platform. So if you have a Facebook account, you can use this model on its own. And that was trained on billions of Instagram posts and Facebook posts. In the multimodal understanding domain, we see GPT-4 being really exciting for a lot of people. This was a popular paper from Microsoft Research in which they were basically just exploring the different abilities of GPT-4V, what it could and could not do. Lots of interesting insights here, amazing things it can do, but also identifying some of the issues in the multimodal domain around hallucination that are analogous to what we see on the generative text side. On the open research and academic side, we see the Lava model, which was another multimodal model. Others like Mini GPT-4, which came out from the Middle East. And then with startups and smaller companies, there's models like the Fuyu 8B, which was released openly. And people are even doing things like putting these different types of models together. And so we see composite models like Video Llama, where you can do things like interrogate video clips using the multimodal capabilities of these models. Switching over to video, we now also see synthetic video being generated by multimodal language models. Stability AI released stable video diffusion, where you can input an image and get back short video clips generated from it. And Meta expanded their EMU model with EMU Video and EMU Edit. A leader in this space is Runway ML. So here on the left, we see synthetic images, which are generated by Midjourney from a text prompt. And then these are fed into Runway as input. And then on the right, you see the videos generated from those images. So basically here, we're seeing 100% synthetically generated media from generative AI. They also, they just recently released a new model, Gen 2, and then there's this clip here, which was popular on social media, where you can do in-painting, so you can take something like a still image and then in-paint parts of it, and it will just animate those parts of the image to create a video from it, which is pretty neat. Now, combining audio and video generation together, we've seen the rise of digital clones or digital avatars. So companies like HeyGen here on the left, this is not a real person. This is a generated video of him speaking and moving with this generated avatar. Basically, there are companies that will deepfake you if you give them enough data about yourself. And then you can do things like create videos of yourself for social media or instructional purposes in a programmatic way. Microsoft also released a version of this year, available on Azure and Alpha at their Ignite conference, although admittedly their current offering is a little more wooden than some others. So in my opinion, there's some ways to go in terms of this technology evolving. We see other research like this being done that's similar. The Animate Anyone paper from Alibaba, the researchers created a generative model where you can take still images and different poses as input, and then it will generate video of the person following those poses. And they make the point that there are obvious use cases for this, like in retail or in fashion, as you can see above. But when they released this, someone basically commented on social media, RIP TikTok dancers, because now if you have a still image of anyone, you can generate a video of them dancing. And Alibaba also coming under fire on social media when it was revealed that they scraped a lot of TikTok videos and used these to train the models without the individual's permission. So this work, like many others, continuing to raise questions about data ownership and privacy and just about whether, because the data is publicly out there, if it's fair game to be used to train models. So we'll continue to see those sorts of discussions evolve in the future as well, just as there have been in the image generation and text generation domains. Furthermore, in multimodal generation, we see applications like generating 3D models synthetically. So here we have an example of text to 3D avatar creation from the TDA model from the Max Planck Institute, where you can type a text prompt and then get back a textured 3D asset from that prompt. So you can imagine in the future making video games with 100% synthetically generated assets, or using these in animated films or other types of media. So we're going to start seeing these types of models being integrated into software and becoming a regular part of creative workflows. And finally, here's one that I think is interesting. Neural radiance fields, or NeRF models. This is an area that's been researched for some time, but they're getting better and better. And we see here from this paper, ZipNeRF from Google Research, this video here is not a real drone flyby video. This is a synthetic video that was generated from still images taken in this house. And a generative model then uses the directional information and the still images to create this very lifelike looking drone flyby video. So you can see very real use cases here. You can imagine in the future, if you want to put your home up for sale on Zillow or rent it on Airbnb or Vrbo or wherever, you can just take a few photos in your home with your smartphone, and then these sorts of videos can be generated completely with AI. Okay, so looking ahead into the future, into 2024 and beyond, What can we expect to see in the coming wave of AI? As many people know, Google recently released their Gemini model, basically to go directly up against OpenAI, given that things with Bard did not go so well earlier this year. And once again, they bungled it and messed it up, at least somewhat, when it came to light that their very slick marketing was not 100% completely real and live in its production in the way that it was presented. And I, for one, am shocked, very shocked, that marketing for an AI product is not 100% authentic and true. But basically, there was a bit of negative pushback about this, and I would say that things continue to be a bit of a struggle for Google. Many people see Google doing this as going directly up against OpenAI, but I don't see it that way at all. I actually see this as Google being in direct competition with the other big tech giant, Microsoft, because as most people know, Microsoft has a very, very close relationship with OpenAI, with GPT powering Copilot, and OpenAI models being trained and hosted on Azure infrastructure. So the future is going to be interesting. It's interesting to see how it'll be interesting to see how this boxing match will play out. Interesting to note as well that certain other tech giants refuse to get involved. These two going head to head in a very public way, but companies like Apple, very noticeably reticent on this front, even avoiding using terms like AI. And their big announcement at the end of this year was being that they released a new ML framework for Silicon. And we even see companies like Amazon seemingly content enough to be a provider of services and foundation models from others through AWS Bedrock. And even though they do have their own Titan model that they've trained, they haven't really made too much of a fuss about it. So it'll be interesting to see how things continue to play out. Okay, so my 4 predictions for 2024 and beyond. We're going to continue to see organizations try to make sense of all the world's information using large language models as well as generative AI. And as part of that, we're going to see new approaches develop, perhaps building on RAG, or maybe approaches we haven't even thought of yet to deal with things like the problem of hallucinations. And the fact that this type of computing is not one we can always necessarily trust. It's not entirely deterministic, like much of the computing we've been used to in the past. Secondly, we're going to see legislation start to catch up with development in AI. Right now, the robots are winning, but very recently, legislation came out of the EU with the passing of the EU AI Act. Biden issued an executive order on AI, and Canada has the AIDA on draft. So we can expect more legislation to be coming out very soon. We can also expect to see the pace of innovation slow considerably as the people that do not understand how AI and these technologies work seek to put in place rules about how they can and cannot be used. In 2024 or later, we will also see the very first feature film entirely generated by AI. Whether or not that film will be any good is another question, but we're going to see it at some point in the near future. And as part of that, expect to continue to see the tension and the back and forth of litigation between creative industries like Hollywood and record labels and publishing houses increase. And we'll also get to see how that is going to play out as generative AI becomes a part of everyday life. And if it's going to be anything like the battle between technologists and record labels in the past, I know which side I will be putting my money on. Finally, there are no signs of things slowing down, so expect to see the scale, investment, and competition in the hardware space continue to explode, as does the size of these models. Obviously, NVIDIA, very dominant in this space, making money hand over fist, despite reports of GPU shortages. AMD is going to be throwing their hat more formally into this ring next year with greater gusto. I'm not sure if I have a lot of faith in that, but we'll see what happens. And we are even seeing startups in the AI infrastructure space offering dedicated cloud infrastructure for AI training, which is not something which used to be as common. So there's a ton of demand there. Expect to continue to see that grow and expect to continue to see the hardware around it evolve as well. In the future, will generative AI models replace professionals like doctors or lawyers? No, I don't think so. I think what we'll see is that the work people are doing with these tools will be different. They'll be able to do the same work that they used to do, only now better or faster. A good example is maybe nurses will be able to provide directions or make decisions or do things in the past that typically only doctors would be able to do. I don't believe we'll see any of these tools, whether they be text models or models for generating synthetic images or video or whatever else. I don't believe we'll ever see any of these tools fully replace those kinds of roles in this kind of way, especially in very specialized domains that require a lot of knowledge in which you need to be very certain and confident about. So you hear a lot of crazy things, people saying things like, it's the end of computing. We're entering a whole new paradigm of computing. It's the end of programming. And in the future, we're just going to be talking to these models and so on. And I don't believe that. I think that's all a little bit over the top. But what I do believe that now is a weird time, and in that we get answers from these kinds of models and these services built on top of them, and we cannot always entirely trust those answers. So maybe we can look forward to a future where we have something like councils of models, right? This is how you interact with people. You go to a doctor, you trust that they are knowledgeable, but if you don't, you can go out and you can get a second opinion because there's a reason for that. Or we have bodies and councils that make decisions about things like governments or boards of directors that sort of lean on the wisdoms of crowds type of effect. And they all have different variable inputs into the decisions they collectively make. And you can imagine there being some sort of analog to this in the future with AI. So I'm much more bullish on this sort of thing happening as opposed to AI entirely taking someone's job or their job being replaced by a model. And I think that the way we interact with these models is different now too. The way in the old days we used to trust everything. And now when you use ChatGPT or many of these generative models, you basically treat them like a really bad assistant. You can't always trust their responses, but at least you have something to start from, which is better from starting from zero and doing all that work yourself. So as things continue to progress, we are going to see a lot of this hype fade. As the technology progresses, we are going to find some sort of steady state where LLMs belong, how they fit in, and how we can continue to use these in the near future and beyond. And this is going to be driven by a mixture of innovation on the side of the companies releasing these models, as well as consumers figuring out the use cases that they actually want these models to be used for, what does and doesn't work, and how value can be provided. So 2023 was a truly remarkable year, and I'm looking forward to 2024. Thank you very much for listening to this presentation. And if you're interested in learning more, please check out NLP from Scratch at nlpfromscratch.com. Thank you very much.